So let's start. We're starting with matrices now. So a matrix is a rectangular way of displaying numbers or letters. It can be, so they call it elements. So we know we can see them like that. So we can have letters or we can have numbers, whatever. And we just use square brackets to put these elements in. So a matrix can be, we normally label a matrix with a capital letter. So we'd say in that example there, we're calling that A. And the way we say the order of the matrix, the order is like the size, okay? So you say the number of rows first. So if you have a look here, this one's got 1, 2, 3 rows and 2 columns. So then you say the columns second. So column 1 and column 2. So you can see this matrix A here is a 3 by 2. So the order of the matrix, if they ask you, it's like they're asking you what's the size of it. So the order, and we say rows by column. So when we describe the order, we often put it in little curled brackets. So say up here, if I did this one, the order of this one is, how many rows is it? 2. And how many columns? 2. Yeah, so I see how I've done curled brackets there. So that's the order. So if we call this up here, we've called it matrix A there. So I'll just make another example here. So I might call this matrix D. So I do this and 6, 3, 2. I just made that up. So what's the order of this one first? What's the order of this? 2 by 3? Good. So 2 rows, 3 columns. So what we can do is we can locate an element inside that matrix with, they can give us an instruction. So because I called this matrix D, they often say little d, and if I said little d and I said 2 and 1, what they mean by that is that you need to go to row 2 and column 1. So if I do that for this one, here's row 2 and here's column 1. If they were asking me for D, 2, 1, that means they're asking me to, for number 3, find number 3. So they give the rows first. So if you look here in the notes, they said each element in the matrix is identified by a row and column number. So here, so they're saying I is the row number and J is the column number. So here, when they said A32, you'd go to row 3 and column 2. So it would have been -4 there. Okay, so wait a minute. Okay, so I'm going to do this question. This is from an exam, and kids found this hard. So they found it confusing. So it was one of the ones that wasn't done well, and I found even it's still one that everyone struggles with. So you can watch this video again later if you need to. So they've said let matrix M here. So we've got matrix M, and it has the element in row I and column in J. So what they're saying here, it's just their way of saying they have to tell you the rule that I just said before, that they're going to quote the row first and then they're going to quote the column second. So it's just a way of saying that. And what they're saying that in this matrix M, it was determined by using the rule, and you have to work out which rule. So say if we're going to try this rule here, they're saying that the element, the way I find this number here would be that I add so that's its row, isn't it? And then its column, and then I -1. So in this spot, what row is it? It's row 1, so it'd be 1. What column is it? 1 plus 1 minus 1. What does that equal? No, that equals 1. So that worked for that one, didn't it? Yeah? So let's try it for this one. What row is that? Row 2. And what column is it? Column 4. And then -1. What would that equal? So 5's not 6, is it? So it's not this formula. Can you see that? Yeah. So then we might try so we might try the next one. So I'll do it in another colour so you can see. So we'll try this one. Okay, so let's test a couple. So we've got to do, the rule says 2 times the row. So what's the row for this one? So it's 2 times 1 plus, minus. What was the column? 1. Oh, God, sorry. Minus 1 plus 1. So what would that be? That'd be 2 minus 1, 1 plus 1 equals? Isn't that 2? Is that 2?
Yeah.
Yeah. So this one's not in, is it? No?
No.
Alright, so let's try, I'm going to try this one down the bottom. Alright, so if I was doing this number, it's saying row plus column, which is 1 plus 1 plus 1. That doesn't work either, does it? No. So that one's not in. Oh, God. Which one's it going to be? I'll just change colours. Alright, let's try this one. I'll rub them out. Alright, so we'll go to, I'm doing this one. What row is this? It says to go row plus the column, which is, you got to do 2 of them. 2 times 1 minus 2. What will that equal? That'll be 3 minus 2. That equals 1. That works, doesn't it? Yep. So let's try this one. We've got to do the row number, which is 2, plus 2 times the column number, which is 4, and then we do minus 2. So that would be, what does that equal? 8. No, so that didn't work either. So we'll try that last one. Does this one work?
Yes.
So let's try it. So if we try this number again, it'd be 2 times 1 plus 1 minus 2. That gives, does that give 1? Yep. Doesn't it? And then test this one here again. So we've got, it'd be 2 times, 2 times 2. We're doing this rule. And plus 4 minus 2, sorry, and that equals 6, doesn't it? Yeah? So this is the answer, sorry. So it took a while. Don't do that. Okay, so here let's try another one of these. This is from an exam. So once again, so they said the table below shows information on how to set up matrix A and matrix B. Okay, the element in row I and column J of matrix A is IJ. They're just telling you like what I told you. Normally they quote the row first and the column second. And then, now the question's asking us to add A and B. So we'll learn how to add matrices later, but it's pretty easy. You just add the same spot. So let's go make a matrix A, like go create it. Now they're saying matrix is a 3 by 3, so it has what? 3 rows?
3 columns.
And 3 columns. Good. Okay. And what they're saying, the rule to make it here is you go 2 times I, so 2 times the row plus J. So that would be 2 times 1 plus 1. So what does that one equal? 3?
3.
And then this one would be 2 times 1 plus 2, which equals 4. And what's this one? 2 times 1 plus 3, which equals 5. This one would be 2 times 2 plus 1, which equals 5. Yeah? And then this one would be 2 times 2 plus 2, which equals 6. And this one will be 7. No? 2 times 2 plus 3 is 7. Okay, this last one, 3 times 1 plus 1 equals 4. Yeah? And then this one will be 5.
Wait,
Did I do it wrong?
Yeah, shouldn't it be 2 times 3? Yeah.
Oh yeah, 2 times 3 plus 1 is 7. Yeah, and this one will be 2 times 3, 6 plus 2 is 8 and 9. So if we tidy that up, so it's a bit neater, we have 3, 4, 5, 5, 6, 7, 7, 8, 9. And then you've got to go create B. And B is a 3 by 3 too. And you are simply minusing the row from the column. So 1 minus 1 is 0. 1 minus 2 is -1. 1 minus 3 is -2. What about 2 minus 1 is 1. 2 minus 2 is 0. 2 minus 3. 3 minus 1 is 2. 3 minus 2 is 1. And 3 minus 0. So then the actual question is you have to add those together. So you've actually got 3, 4, 5, 5, 6, 7, 7, 8, 9. And then you're going to add this one. So do you remember how to add? You just add the same elements. Remember that? We'll do that later. But here you go. So 3 plus 0 is 3. 4 minus 1 is 3. 5 minus 2 is 3. 5 plus 1 is 6. 6 and 6. And then this one is, what's that? 9, 9 and 9. So the answer was D. Good. Okay, we have different types of matrices, and you have to know what they are in case they are setting up a situation and they might say write this information in a row matrix or write this in a column matrix. So you do need to know, but it's pretty self-explanatory. You can see a row matrix simply has one row. So you can see when they did the order of this one, it's a 1 because it's one row by there's 4 columns, so it's a 1 by 4. A column matrix obviously has one column. So there you go. And so this one's order is 3 rows and 1 column. A square matrix just means it has the same amount of rows and columns. So you got a 2 by 2. So you could have a 3 by 3 is also a square matrix, yeah? And if you have a diagonal matrix, what that means is that you only have numbers on the leading diagonal. Leading diagonal means it starts up here in the left-hand corner, and then it goes down like that. So can you see there's the only numbers there, and the rest is 0. That's a diagonal matrix. That's what, if you see that. So this one, yes, you're correct. This is also a square. What's its order? Is a 4 by 4. And to be honest, you can't have a diagonal matrix if it's not a square, because you can't get a diagonal otherwise, okay? So we have other ones too. Now these ones are new, so these haven't been always in the course. So what we've seen now is they might talk about upper triangular matrix. If you have a look, can you see the numbers are only in that top corner like that? That's an upper triangle. The lower one, you can see there's a triangle there. The rest are zeros otherwise. So you always have your reference book, so you can always refer back if you're a little bit confused if they ask. Now, this transposing a matrix, this is also new, and it comes up a little bit and then kids have forgotten about it by the time they're in the exam. So when you're asked to transpose a matrix, all you have to do is switch its rows and columns to be the opposite. So if you have a look here, they have transposed this matrix. Can you see there was the 2 columns like that? They've now become rows like that. Yeah? So you transpose. So if I have to transpose this one has now gone along like that. Now what you'll see is you'll see this little command like that. They'll use a little T there. They've asked you to transpose it. So if I did another example and I had like this, and I asked you to transpose it, so you would just simply change it. It becomes 3x 5 and 2a 4, like that. Okay, so the rows became columns and as such. Okay, now, so you'll see that that's all you're asked to do if you're asked to transpose it. We have a symmetric matrix, is a square matrix that is unchanged by transposition. So you can see here, if we change these to rows, so I put those rows to a column, and the second one, did I end up with the same matrix there?
Yep.
Yeah. See how that is the same as that? So that is called a symmetric matrix. If you transpose it, you end up with exactly the same thing. So a symmetric matrix is going to be a square matrix as well, because you have to have the same. And they've just mentioned there too, they've said that the leading diagonal it's a mirror image. So what you mean, see how, look here, if that was a mirror, can you see how if 2 was looking at it, it sees 2? Yeah? And if 4 is looking through the mirror, it sees 4. Can you see that? Yep, that's what that means. So the leading diagonal acts as a mirror. So I've never really seen a question except for maybe, is this a symmetric or something? So you can always refer to your reference book to check if you can't remember what that is. All right, so we're looking at different matrices, and this identity matrix, this one's really an important one. If you have a look here, what do we know about, what's the order of this identity matrix? It's a 3 by 3, so what do we call that? That's a square matrix. So an identity matrix is a square matrix, and what else do you notice about it? It has ones on the leading diagonal, doesn't it? Yeah? So ones down here and everything else is 0. What you should remember about the identity matrix, it's like a number 1. It acts like a number 1 in matrices. So what I mean by that, if I times 3 by 1, what do I get? 3. So what happens if you have a matrix, say I have matrix A, so sometimes we just symbolize matrix A like that, and if I times it by the identity matrix, now I'm telling you, identity is like a number 1. So what do you think your answer will look like? If I did 3 by 1 equaled 3, and now I said A by I, which I is the identity matrix, what do you think you're going to get? A, matrix A. So can you see, timesing something by the identity matrix, if it can be done, won't change that matrix, yeah? And we sometimes need it to be able to do some other things. But that's what, if you can remember, that will help you. And then we've still got some other types of matrices. A null matrix just has zeros in all of it. Pretty easy. And then if 2 matrices are equal, they have to look exactly the same. So we can see here, if they're going to be equal, they have to look exactly the same. So that's the only way a matrix is equal to another matrix. All right, so let's keep going. So here's an example of the transpose. So that's pretty easy. They've actually just told us transpose. They didn't use the T. So transpose this just means we have to make the rows columns. So 2, 7, 10, and then I'd have 13, 19, 8. So where's that answer? Yep. Row 1 always becomes column 1. So then that C is our answer. All right. Okay. Entering into your matrix into your calculator. I've put this in here, but you don't have to do it. The only times you really have to store a matrix is when you've got a whole heap of questions. So maybe in your textbook when you're doing it, this is a long-winded way of storing. You know, you can type in your matrix 2, -3, 4, and 1, and you can use this little button, the store button, so You get this button by going Control Variable, and the variable's just above the number 9, and then you can say A, and that will store it. I'll go show you on the projector with the laptop, iPad. Yeah.